Now that you're a master at balancing chemical equations, let's talk about the different types of chemical reactions. Our first type is double displacement, and this occurs when two different compounds react to form two new compounds, hence the double. Meanwhile, in single displacement occurs when an uncombined element, so someone who is single, replaces an element that is part of a compound. A synthesis reaction occurs when two or more substances combine to form one more complex substance, which is the definition of a synthesis. Decomposition occurs when one complex substance breaks down into two or more simpler substances. It literally decomposes. And our fifth type is a combustion reaction, which is a type of double displacement reaction where a compound is reacted and burnt with oxygen gas to produce carbon dioxide gas, water, and heat. Let's dive into each of those a little bit deeper. So why are the types of chemical reactions important? Most reactions will fit into one of the 5 types. There are some exceptions, there always are. We're not going to get into them in this class. Scientists use the type of reactions to predict the products. If they know what they have, they can figure out what they're going to get. Being able to write a chemical equation does not necessarily mean that reaction will actually take place, and we're going to talk about how you'll figure that out coming up. So let's talk more about double displacement reactions. So this is when two different compounds react to form two new compounds. Sometimes it is also called double replacement. I sort of use both. So the general formula is AX plus BY equals AY plus BX. So we started with two compounds, we finished with two compounds, but you'll notice they essentially switched partners. The Y used to be with the B, but now it's with the A, and the X used to be with the A, but now it's with the B. Double displacement reactions, one of the products formed must be a precipitate, a solid, a liquid, which is going to be water, or the problem is going to flat out tell you that something is a liquid, or a gas, which is our diatomics, meaning our Brinkelhoffs, ammonia, which is NH3, or it's going to be indicated that this thing is a gas. So in order for this reaction to happen, like we mentioned, not all reactions happen, one of the products has to be a solid, liquid, or a gas. Now just real briefly, there is a type of double displacement reaction that is called a neutralization reaction. And this is when an acid reacts with a base, yes, those acids we learned about in our last unit, to produce a salt and water. That's a special type of double displacement reaction that we call a neutralization reaction. So what are some examples of double displacement reactions? So we have calcium hydroxide, aqueous, plus hydrochloric acid, producing calcium chloride and water. We could also have sodium hydroxide plus calcium 2 chloride, copper 2 chloride, producing sodium chloride and copper 2 hydroxide. Now you will notice that each of these reactions, one of the products is a solid, liquid, or a gas. We had water here that's always going to be a liquid, and we have copper 2 hydroxide, which is going to be a solid. Now, how did I know that that was going to be a solid? So a soluble solid is a solid that readily dissolves in water, and it gets the state of matter AQ, aqueous. An insoluble solid is a solid that dissolves to such a small degree that it is not detectable to the naked eye, so we still just call it a solid. Then there's also something called a precipitate, which is an insoluble solid that forms during a chemical reaction. It will look cloudy or it'll look like a solid. You can see them occurring in these two pictures. That also is going to get the state of matter solid. So this brings us to our friends, the solubility rules. So these are a set of rules or guidelines that indicate whether a substance will be soluble water, aqueous, or whether it will be insoluble in water, solid. This exact set is located on the back of your periodic table, and you need to know how to use them. How do you use them? You're essentially going to read these 9 solubility rules, and if you say yes to one of them, any one of the 9, then it is going to be aqueous, AQ. If you say no to all of them, 9 no's in a row, it does not meet those requirements, then it is going to be a solid in water. So let's practice with that. Look at the solubility rules in the back of your periodic table, And we're going to determine if sodium sulfate is soluble or insoluble. So you look at your solubility rules and you ask yourself some basic questions. You start with the first one. Is one of those two an alkali metal ion? Well, right off the bat, sodium is an alkali metal ion, so I have said yes to one of them, meaning it's automatically soluble. Let's do calcium acetate. So I go through my questions once again. Alkali metal ion, nope. Ammonium ion, nope. Number 3 says acetate ion, so I have said yes, meaning it is also soluble. All right. I want you to try these next 4 on your own. Once again, you're just going through the solubility rules, and if you say no to all of them, it's going to be insoluble. If you say yes to one of them, it's going to be soluble. Pause this video, come back when you're done. All right. Iron 2 hydroxide is insoluble because you should have said no to all of the rules. Aluminum phosphate is also going to be insoluble because you should have said no to all of the rules. Meanwhile, lithium hydroxide you should have gotten as soluble because you would have said yes to rule number 1, alkali metal ions. And then lead 2 sulfate you should have gotten as insoluble because while you would have been tempted to say yes to number 6, which says sulfate ions, you would have noticed that it said except when paired with strontium, barium, calcium, silver, mercury, or lead, which is what we had, meaning that 6 was actually a no, as were all the rest. See, soluble versus insoluble is not so bad. So now let's practice with double displacement. I want you to write the balanced chemical equation, something you already know how to do, indicating the state of matter of each. If the reaction will not take place, you are going to write no reaction, NR, after the reaction arrow. If the reaction does take place, you are going to write out the whole reaction. Remember, for the reaction to take place, one of your products, the second part, has to have a solid, liquid, or a gas. Pause this video once you have written out your balanced chemical equations and determined whether the reaction occurs or not. Unpause the video when you're ready to check your answers. All right, so let's take a look. You should have gotten BaOH2, aqueous, plus 2HCl, aqueous, produces BaCl2, aqueous, and 2H2O, liquid. Remember, water is always a liquid as far as its state of matter is concerned, so we are good to go. As far as 2, you should have gotten 3H3PO4 aqueous plus NH4OH aqueous produces NH43PO4 aqueous plus 3H2O, liquid. Once again, water is always a liquid. Meanwhile, number 3, when you did NaCl plus LiBr, when you looked back on that one and looked at your products, you would have said yes to one of the rules for them getting both of them to be aqueous, and since both of your products ended up being aqueous, that means no reaction would occur. Now that you're a double displacement master, let's talk about single displacement. This is when an uncombined element or a diatomic molecule replaces an element that is part of a compound. It is also called single replacement. Once again, I use both pretty interchangeably. So the general formula is A plus BX produces AX plus B, so that X swapped partners. So cations will replace cations and anions will replace anions. What type of ions do metals form? Well, they form things with a positive charge, making them cations. Meanwhile, nonmetals form anions, things with a negative charge. The requirements for this is that it must follow the activity series. So what is the activity series? It's an arrangement of elements organized in the order of ease with which they undergo certain chemical reactions. They are used to predict products for single displacement reactions only. You do not use them for double displacement reactions. There are 2 different activity series. There's the metal activity series and the halogen activity series. You are provided both on the back of your periodic table. Elements can replace any element below it on the activity series, but not any element above it. So in order for that single one to move the double one, it has to be higher on the activity series. This is the activity series that you were provided on your periodic table. So you can see since lithium is the highest up, it can essentially displace any of these. Similarly, if you have a halogen, fluorine can displace any other halogen because it's at the top. Meanwhile, gold isn't really going to be displacing anybody because it's at the bottom. Same is true of iodine. So you just find your two metals or halogens, and the one that's alone needs to be higher up than the one in the couple in order to displace it. So the activity series decreases as you move down the group. That's why the arrows are pointing up. Metals higher on the list will replace metals lower on the list. A metal lower on the list will not replace a metal above it on the list. In this case, we write NR for no reaction. The farther apart two elements are in the series, the more likely the higher one will replace the lower one. So what are some examples? We have copper metal reacts with silver nitrate to form silver and copper nitrate. We have lithium metal reacts with water to form lithium hydroxide and hydrogen gas. So we have copper all by itself, and we find it on our activity series. And then we have silver with the couple. We notice that silver is below copper on the list, which means copper is going to displace it and create copper 2 nitrate, while silver is then going to be by itself. Similarly, when we have lithium and hydrogen, we are going to find them both on the list, and we see lithium way up at the top, and H2 is there near the bottom, right above copper on our list. So since lithium is higher, it's going to displace that hydrogen, and hydrogen is going to end up all by itself. Now I want you to determine whether in these single displacement reactions the reaction occurs or not. You were just writing no reaction or reaction. Pause this video, use your activity series, and come back when you're finished to check your answers. All right, at first we're comparing silver and copper using the metal activity series. Since silver is lower than copper on the activity series, no reaction is going to occur. In our next example, we were using the halogen activity series because we were comparing fluorine to bromide. Since fluorine is above bromide on the activity series, that means the reaction will occur. We were back to using the metal activity series in our second example, where we were finding magnesium and zinc. Since magnesium is above zinc, the reaction is going to occur. And last, we were comparing bromine to iodine. And since bromine is above iodine on the table, no reaction is going to occur. See? Super simple. So our third type of reaction is a synthesis reaction. And a synthesis reaction occurs when two or more simple substances combine to form one substance that is more complex. You do not have to worry about states of matter for synthesis reaction. Yay! So the general formula is A plus B equals AB. They are getting synthesized together. Some examples for you. 2Fe plus 3Cl2 equals 2FeCl3. Or 2Na plus Cl2 produces 2NaCl. We take two or more things that are separate and we jam them together to create one thing. For your practice for this, I want you to write the complete balanced chemical equation for the following synthesis reactions. Make sure to crisscross all of that good stuff. When you are finished, come back and continue watching this video to check your answers. All right, so you should have gotten 2Cu plus O2 produces 2CuO. For number 2, you should have gotten 4Al plus 3O2 produces 2Al2O3. For 3, you should have gotten 3Ca plus N2 produces Ca3N2. And for the last one, you should have gotten S8 plus 8O2 produces 8SO2. How'd you do? Hopefully well. If not, go back and try again. Our fourth type of chemical reaction is a decomposition reaction, which, if you remember, is a complex substance that breaks down into two or more simpler substances. Our general formula is AB produces A plus B. The AB decomposes to its component parts. Once again, we do not have to worry about the states of matter. Oh, good day. So some examples, you could be told that ammonium nitrate decomposes to form dinitrogen monoxide in water, which you would write out as NH4NO3, arrow N2O plus 2H2O. Or you could be told that sodium nitride decomposes to form sodium metal and nitrogen gas, where you would write 2NaN3, producing 2Na plus 3N2. Got it? All right, I want you to try this one on your own. Pause this video and write the complete balanced chemical equation for the following decomposition reactions. Come back and continue to play this video when you're ready to check your answers. All right, so you should have gotten 2H2O, arrow 2H2 plus O2. You should have gotten 2NaCl, producing 2Na plus Cl2. And you should have gotten 2NH3, producing N2 plus 3H2. How'd you do? And now, last but certainly not least, is our combustion reaction. And this is a type of double displacement reaction in which hydrocarbons, which are substances made of carbon and hydrogen, and sometimes oxygen, are burned in oxygen to produce carbon dioxide and water vapor. So all reactants and products are in the gas or liquid state. So our general formula is going to be Cx, where x will be a number, Hy, where that's going to be a number. That's usually going to be a liquid, plus O2, which is always going to be a gas, producing CO2, which is also going to be a gas, plus H2O, which is always going to be a liquid. So some examples, we have CH4 liquid plus 2O2 gas, producing CO2 gas plus 2H2O liquid. Another example is 2C2H6 liquid plus 7O2, producing 4CO2 plus 6H2O. All right, I want you to balance the following combustion reactions. Now, some things to remember. Balance hydrogen and oxygen last because they are going to be your two most difficult ones. Also, if you get stuck, try multiplying the hydrocarbon by 2 and then start over. That is my advice for combustion only. Do not try it on any of the other ones. All right, using my advice, pause this video and come back when you are ready to check your answers. Let's see how you did. The first one should have been simple, where you got CH4 plus 2O2 producing 2H2O plus CO2. Number 2 is what I was talking about, that you should multiply the hydrocarbon by 2 and start over if you got stuck. If you did that and multiplied that hydrocarbon by 2, it would have then been easy to balance even though you got really big numbers with 37O2, 26H2O, and 24CO2. 3 was back to being an easier example, where you should have gotten C3H8 plus 5O2 produces 4H2O and 3CO2. Combustion reactions are some of the most difficult to balance, but I have faith you're going to get the hang of it. That's all I've got for you for chemical reactions. Come to class ready to work.